So this is the third video in the organic section, and it's on naming alkanes. So we're going to look at how to name alkanes based on how many carbons they contain, be able to name any what is called a substituent or a branch group, and therefore be able to combine the two previous points to give the full name of a variety of alkanes. So there are three stages you should follow when naming alkanes. The first is to identify and name the longest continuous carbon chain. And to name this, it's actually broken into two parts. The first part of the name depends on how many carbons are in the longest continuous chain. Now this is easier said than done. Let's have a look at an example. Let's have a look at this molecule here, this alkane. Now it might look like the obvious longest chain is here. They're in pretty much a straight line. You don't have to go back, so it's continuous. But that wouldn't be correct. Now, I hope you can appreciate that this is the same molecule I've just drawn. I've omitted the hydrogens just for clarity's sake. So, the longest continuous chain, which looks more obvious, is along the top there. But because of the properties of single covalent bonds, it's not the case. When you have single covalent bonds, you can actually rotate around the bond. So, if I just rotate this here, it's now much more obvious that instead of 5 carbons in the longest continuous chain, you have got 6. So it doesn't actually matter how the molecule is drawn. You have to look for the longest continuous chain. It is actually here with 6 carbons. Okay, so once you've identified the longest continuous chain of carbon atoms, you have the first part of the name. Now with alkanes, the second part of the name is just ANE, which is the end of alkane. All of the types of alkane also end ANE. Now if you think about your name, now this is my name and my parents. Now, we each have an individual name which comes first, but we all share the family name. Now this is a little bit like what we're looking at with alkanes. The last part of the name is the same. It's the alkane family name, whereas the first part is different depending on the molecule. So like we've just mentioned, the first part of the name is based on the longest continuous carbon chain. Now this table is very important. I'm not going to go through it, but these are the prefixes for the different numbers of carbons. You need to memorize this table. So I would pause now and add it to your notes. Just a point that at GCSE you needed to know the first 5, at AS level you need to know the first 8. So once you've got the name of the longest continuous carbon chain, you have the basis for the overall name. So steps 2 and 3 are for the added detail, which makes different molecules unique from each other. Now, any atoms or groups which branch off the main carbon chain are what we call substituent groups. Now, each substituent group has a name and needs to be included in the overall name of the chemical. Now we're just talking about alkanes for now, which means we are only containing carbon and hydrogen. So groups, branches, which contain just carbon and hydrogen are called alkyl groups. So just like for when we named the main chain, it's the same sort of process. The name of the alkyl group depends on how many carbons are in that group, and the second part of its name is its family name. So it's an alkyl, so the family part of that name is just YL. Now, an important point, if there are more than one different substituent groups, they need to be put down alphabetically. Even if that doesn't seem to follow for the positions in the structure, that's not important. The procedure is to put them alphabetically. So as I was saying, naming the alkyl groups is done in a very similar way to naming the longest carbon chain. You can see here that with one carbon, it starts with meth, and then you just add the family name, which in this case is YL. So again, pause, compare this to your previous table. So if we go back to our example, we've identified the longest continuous carbon chain. So we know the name is based on hexane because there are 6 carbons. Now we can see that there is one group which branches off from the main chain. Now this alkyl group has 2 carbons, so this substituent group is called ethyl. So now that we have the names of the main chain and the substituent group, there's just one more thing we need, and that is to identify the number of the carbon that the group is attached to. So what does this mean? Well, if we look at our example, you number the carbons in the longest chain. Now obviously you could start at this carbon or at this carbon. So let's say I start at this carbon. In this example, the substituent group would be attached to the 4th carbon. Now if I'd started at the other carbon, the substituent group would be attached to the 3rd carbon. Now when you are deciding which carbon the groups are attached to, you need the lowest possible numbers. So in this case, we would have the ethyl group being attached to carbon 3. So for this molecule, it is based on hexane. We have an ethyl group, and this ethyl group is attached to the 3rd carbon. Now note that I put this little dash, and you have to put this whenever you have a number next to a letter, or a letter next to a number. So when you're identifying a number, make sure that it's the lowest number possible, the lowest combination of numbers. And when you have more complicated molecules, it does not matter if the numbers are in order in the name. What matters is that the substituent groups are in alphabetical order. So let's have a quick look at a few harder examples. Okay, so in this instance, we have 1, 2, 3, 4, 5 carbons in our longest chain. So it is based on pentane. Now in this example, we have two branches coming from the main carbon chain. Now you need to identify every branch. But because this is the same substituent group, we do this in a slightly different way. So the group itself has one carbon, so it is a methyl group. Now because we have two of them, put di in front. Dimethyl, two methyl groups. So that's step 2. Step 3 is to identify the number of the carbons on the chain that they are attached to. So we can either go from left to right or from right to left to label them. And hopefully you can see that by starting on the right hand side, we have the lowest possible numbers. We have 2 and 3, as opposed to 3 and 4 if we'd gone the other way. So in this case, the 2 methyl groups are attached to carbons 2 and 3. Now, when we have a number next to a letter, we have to put a dash in between. When we have two numbers, it's a comma. Well, let's have a look at another example. Now, I'm going to keep it very similar, just so that you can see the key differences. So hopefully you can see the only thing I've done differently is to add one more carbon with its hydrogens. So, first step is to identify the longest chain. Now once again, the longest chain is 5 carbons, so it is based on pentane. Now once again, we have 2 different substituent groups, but this time they are actually different. So this one here has 1 carbon, so it is a methyl group. This one here has 2, so it is an ethyl group. Now we put methyl second and ethyl first. This is because ethyl obviously comes first alphabetically. So that is step 2. Step 3 is to identify the numbers. So once again, starting from the right hand side gives us our lowest combination of numbers. So the ethyl group is attached to carbon 3, and the methyl group is attached to carbon 2. So our full name for this molecule is 3-ethyl-2-methyl pentane. Just notice that when the 2 goes in between 2 words, you need the 2 dashes. That separates whenever you have a number next to a letter, or a letter next to a number. So hopefully you now know the prefixes for when your longest carbon chain has between 1 and 8 carbons. You should be able to name basic substituent groups and be able to name a range of alkanes, both straight chain and branched.